Hello, this is Mr. Angsman, and this is the first part of your notes for section 10.1. So chapter 10 is on chemical quantities, and the learning goals for section 10.1, we want to convert among the mass and number of representative particles of a substance. This first learning goal, that will be covered in the next section of notes. But we're going to look at these next two today. We're going to explain how chemists determine the number of atoms, molecules, or formula units in a substance, and determine the molar mass of an element and of a compound. Okay, so let's skip over those. Okay, so the first question is, what is a mole? So a mole, it's this little brown furry creature that digs up my yard in the summer, but in chemistry, it's a very important concept. So we use the mole to talk about measuring amounts of a substance in chemistry. All right, so a mole is defined as 6.02 times 10 to the 23rd representative particles of a substance. Now that number is also called Avogadro's number, so you'll hear it referred to as Avogadro's number every once in a while. Okay, so the mole, it's an SI unit for measuring the amount of a substance. And we talk about representative particles. No, so representative particles are the smallest part of something that is still considered that thing. So they're the very small particles that we talk about in chemistry, like atoms and molecules and formula units and ions. So like for an element, the smallest part of an element is the atom, okay? So these are the smallest part of a substance that is still considered that substance, okay? Now the mole, what we do with that is it allows us to consider or count the number of particles that are in a substance without just counting them out one by one. Because when you're talking about atoms and molecules, they're very, very small things, and it's not conceivable to just count them individually. So the concept of a mole allows us to determine how many of those particles are in a substance without directly counting them. We can figure out the mass of that substance, and then we can use the concept of the mole to convert to the number of particles. So those conversions will be done later, but this is the conversion that you'll be using to determine the number of particles, where we say 1.00 moles is equal to 6.02 times 10 to the 23rd representative particles. So there's going to be a lot of conversions using this, but that'll be for a different day, okay? So that's the concept of a mole. Now the other thing that we're doing today is looking at the concept of molar mass. So the molar mass is the atomic mass of an element expressed in grams. That's the mass of 1 mole of an element. So this is information that we can get from our periodic tables, and I'll show you the periodic table in a little bit. But this first one right here, we have 1 mole of sulfur atoms, that's 32.1 grams. So if we can measure out 32.1 grams of sulfur, that tells us we have 1 mole, and that also tells us that we have 6.02 times 10 to the 23rd sulfur atoms in that container, right? So these numbers here are the atomic masses from the periodic table. The atomic mass from the periodic table is also the molar mass of a mole of that substance. Okay, so we say 1 mole of sulfur atom is 32.1 grams. 1 mole of carbon atoms, that's 12.0 grams. This number here is wrong. For iron, it would be 55.8 grams of iron would be 1 mole. Okay, so that's what the molar mass is. It's just the mass of 1 mole of a substance, and we can get those numbers from the periodic table. So here's a copy of what the periodic table looks like. The numbers that we're looking for are the atomic masses, which is on your periodic table, it's that bottom number right below the symbol, okay? And for the molar masses, we're going to take those numbers and we can round them off to a tenth. So like oxygen, it says it's 15.999. Well, we can round that off to 16.0. Something like fluorine, it says 18.998. Well, we can round that off to 19.0. So we can take the numbers that we have here for the atomic masses, round them off to a tenth of a gram, and that's going to be the mass of 1 mole of all those elements. Okay, now the next step excuse me, is to figure out the molar mass of a compound. Well, when you're talking about a compound, that's going to be a group of elements chemically combined. We're just going to add together the masses of the elements to get the molar mass of the compound. So to calculate the molar mass of a compound, find the number of grams of each element in 1 mole of the compound, then add the masses of the elements in the compound. So the examples that are in this picture right here, we have this 1 mole of parodichlorobenzene. All right, so the formula is C6H4 and Cl2. So if we want to get the molar mass of that compound, we're going to look up carbon on the periodic table, and we're going to add 6 of those, so it'll be 6 times the atomic mass of carbon. Then we look up the mass of hydrogen, we're going to multiply that by 4, and then we look up the mass of chlorine, we're going to multiply that by 2, and then you just add all those together and you get 147.0. Again, all the masses can be rounded off to a tenth. For a glucose, that's C6H12O6, we're going to take the mass of carbon, multiply that by 6, the mass of hydrogen, multiply that by 12, and the molar mass of oxygen, multiply that by 6, and we add those all together, and you get the molar mass of glucose. So that's all we're doing to find the molar mass of a compound. We're just adding together the masses of the elements within that compound. The other example here, you have water, so that would be 2 moles of hydrogen and 1 mole of oxygen added together. That gives us 18. Okay. All right, so let's look at a few examples. Now I'm gonna go over these in just a second, but if you want to try these out before I go through the answers, you should pause the video right now. Okay, so here's the answers. So calcium, that's over on the left side, it's element number 20, but for its mass it says 40.078. So when we round that off to a tenth, it ends up being 40.1. And the units of molar mass, you want to put grams per mole for each of these, grams per mole. Oxygen, that's element number 8, kind of near the top right, it says 15.999. Rounded off to a tenth, that's going to be 16.0 grams per mole. Hydrogen, that's on the very top left, that says 1.0079, so we round that off to a tenth, it's just going to be 1.0 grams per mole. A lot of the main elements that we use, like oxygen and hydrogen, a lot of them round off to just 0.0, so it makes the math a little easier. All right, now these are just elements. Now these last two are compounds. So we would have 1 calcium, so that would be 40.1, and then we'd have 2 oxygens, so that'd be 2 times 16, and 2 hydrogens, so that'd just be 2 times 1. When you add all those together, you get 74.1 grams per mole. Then the last one here, N2O, we would have 2 nitrogens. Each nitrogen is 14.0, so that's 28. And add 1 oxygen to that, which is 16, and you get 44.0 grams per mole. So that's how we do molar masses. We're just adding together masses from the periodic table. Okay, so find the molar masses of those. Again, pause the video until you're all done, and then I'll show you the answers in just a little bit. All right, there's all the answers for those. Again, you can just take the masses from the periodic table, round it off to a tenth, and then we add all those together. All right, so that's the first part of the section 10.1 notes. There will be a short assignment on Schoology to go along with this, but have a great day.